Welcome to ClickMyProject.com. Now we see the product for a synergetic use of bloom filters for error detection and correction. Next we see the abstract for the product. Bloom filters provide a simple and effective way to check whether the element belongs to be set. They are used in many networking applications as well as the computer architecture. The bloom filter are used to large database. Example for the Google big database usage. It is reduce the disk lookups. The basic structure of bloom filter has also been extended over the years. For example, counting the bloom filters were introduced allow the removal of element from the bloom filter. To optimize the transmission over the network, another extension known as compressed bloom filter was proposed. Most bloom filters are implemented in electronic circuits. The contents of the bloom filter are commonly stored in the high-speed memory. Required processing is done in a processor or detected circuitry. The set is used to construct the bloom filter is also commonly stored in the lower speed memories. The reliable electronics is becoming a challenge as the technology scale. Errors caused by the interference and radiation and other effects become more common. Therefore, the mitigation techniques are used to different level to ensure the circuit continue to operate reliability. For the bloom filter implementation, memories are critical element. For memories, permanent errors and detect are commonly corrected using the space rows and columns. However, the soft error caused by, for example, by radiation can affect any memory cell, changing its value during the circuit operation. Memory device that continue to operate correctly but has the wrong value its affected cell. The deals with soft error use the use of a per word parity bit or more advanced error correcting codes. Bloom filter provides a fast and effective way to check whether the given element belongs to be set. The bloom filter are used in numerous applications, for example in communication and networking. There are also ongoing research to extend and enhance the bloom filter and to use them the new scenarios, and reliability is becoming a challenge for advanced electronic circuits as the number of errors due to the manufacturing variations. Radiation and reduced noise margin increases the technology scale. In this brief paper, bloom filter can be used to detect and correct the error in the associated dataset. This allows the synergetic reuse the existing bloom filters also detect and correct the error. This methodology to improve the practical designs to effective mitigate errors and reduce the overhead in terms of circuit area and power level. Next, we see the flow diagram for the product. First of all, we apply the given dataset for example of DNA samples. These DNA samples consist of AGF characters to be present in overall datasets. Example, to select any one of the dataset and to store all the values. These values are calculated and corrected the values to be converted into the integer format, because the xylings to be only process wise integer values only. So you pass all the integer values and to write the any one of the text. Then the MATLAB 2013 A software to be processed by this level. Then all the text values to be passing into the Xilinx software. The Xilinx software to read all the values in the given selected text format. Then apply all the values and to passing the parallel bloom filter function. This bloom filter function to be read all the values and to apply the hash values for each and every 4 sections. We represents the 60 values and to we apply the every 4 to process the each one hash values. Then to pass the hash values of input sequence for error detection and correction methodologies. We apply the error detection and correction methodologies based on the Hamming go distance. This Hamming go distance to calculate the error location and to detect the error and to correct the selected located error bits. Then the Hamming code distance is mainly based on to add the 0 bits for selected bit positions. Then to calculate the each and every distance based XOR functions. Then to calculate the parity functions and to replace the 0 to the given in parity bits and to select all the data bits and to be transmitted. Then we are going to apply the error bits because the how to error correct and detect for the our required architecture. Then to apply the error bits and to passing the transmitter section, then the receiving section to be read the all the values and to identify the parity bit calculation, and finally we call detect the error bit location. Then we apply the correcting sequence. The correcting sequence mainly based on in bit inversion logic. Then the bit inversion logic to be corrected for receiver sequence and to pass the final database. The database all of you to be analyze these things and to get the final data characters value in the Xilinx 14.2 software. And finally we see the final output for the product. First we open the MATLAB functions. This MATLAB function is used to select any one of the text value and read all the values and to convert the numerical format, then to write the any one of the text and to apply the Xilinx software. Just run the first function, select any one of the text. This text consists the DNA sample informations and to passing the Xilinx software automatically. Then to open the Xilinx software, our process was mainly developed in VHDL language and our project was due in the Xilinx 14.2 software. This is the overall VHDL functions. This then to select the simulation process and to simulate the simulate behavioral model. Then if the process was running successfully, then to open the iSim project navigator. This navigator used to simulate the our overall architecture process. This process to analyze the all the sequence and to add the error automatically and to correct the error bit location also. This is the iSim project navigator. Our input was automatically passing from the text format. This is all the values. Just we up this is the transmitter bit sequence. This is the return bit addition sequence. RPA means return bit addition sequence. This is the error bit addition sequence and to the corrected error bit addition sequence, and finally we get the error bit presented in location. This location we are given the already. Then the final data bit sequence. This data bit sequence we apply the clocking and to get the final data bits. If the error bit is corrected, then to get the final output data bit. If the error bit is not corrected, we not represent the final data bits. This is the overall data input values for the DNA data sample sequence. This is the sampled sequence for overall architecture process. This is the final data bits for our required Bloom filter architecture.